So give me 2 thumbs up so I know to start the video, rock and roll. Okay, so today we're going to talk about some biodiversity. We'll finish up talking about biodiversity tomorrow. I'm going to talk a little bit shorter today because I want to make sure you have plenty of time to work on your invasive species activities. And I also moved the due date for the invasive species activity to tomorrow so that you have plenty of time to work on it, because I looked at it and I know that some people from other classes have said that they've done it in their biology class. That's great. Make sure you look at the requirements for this one and make sure that you give me the best that you possibly can so that we can have some fun with it. I know it says you must present like 2 to 3 minutes presentation and stuff. Obviously, that's not the easiest thing to do because everybody's in different places. So turn in your invasive species project. Don't stress out over the presentation, and I'll ask any questions that we need as we go. The other big thing that I posted a video for this morning on that I'll talk real quick about is the Change the World project. I made a video for the Change the World project and posted it to the ongoing assignments section. The Change the World project is just that. Find something that lasts about a month in scope that in some way changes your world, changes your ecosystem. It can be something where you're educating your community about an environmental situation. It could be something where you're changing your personal habits. And so if everybody did what you're doing, it would really help the sustainability of the world. Or it could be some type of rehabilitation project where you're building something or doing something that helps the ecosystem in your community. Key thing is that the scope of the project should be a month-long scope. So it should be something that in some way you begin October the 1st and it lasts you until October 30th. I don't expect you to work a couple hours on it every day, but the scope of it needs to be that way. I began this project in AP Environmental Science years ago when we taught it in the spring, kind of surrounding Lent, where you have the 40 days fast, or when you change your life for 40 days around Lent. Obviously, this is not Lent. Obviously, it's only 30 days, but it's another way to think about how we can change our world and how we can affect our ecosystem. The details of that are posted on the front page, and they kind of take the place of where the leaf collection was as well. First 6 weeks, the leaf collection is your big project. Second 6 weeks, this is your big project. So really focus on this. Be thinking about what you're going to do. You have a week to tell me what you want to do. You don't have to be perfect about it, but you need to have some idea next Thursday. When I ask you what you're doing for your month-long Change the World project, you can give me a solid answer. I would suggest probably telling me before next Thursday, so if I have a problem with it, or if it's not good enough, or if it's maybe too much, I can say, hey, calm down, let's think about something different, okay? Any questions about that before we roll on? Like I said, I have a video posted and you can read about it and you have a week to think about it. Got a bunch of people on the Zoom, so probably gonna have a little bit shorter Zoom today. Just gonna finish up these notes, and I wanna give you some time to work on your invasive species project. I changed the due date if you're just logging in. I changed the due date from today to tomorrow on that because I felt like I'd rather give you a little bit more time and see some solid information on that. All right, if there's no questions, we're gonna rock and roll with biodiversity. Ready to roll? All right, so yesterday we talked about ecosystems and evolution, how living things came to be. Today we're kind of just talk about the biodiversity of our planet and how humans affect the biodiversity of our planet, how humans affect speciation, and then the flip side of speciation, extinction. So what we have here, there's about 1.4 million described species. Some people say 10 million. Some people say there could be as many as 100 million distinct species on our planet that we just haven't named and haven't gotten to. So that number varies incredibly because there's enormous parts of the world, like the bottom of the ocean and the deepest, darkest parts of the rainforest that we just haven't gotten to yet. And so we're getting there, but definitely millions upon millions of different species on our planet. So we have something called background extinction rate. Background extinction rate is the rate at which species on Earth went extinct before humans started changing the world. So for the first 3.7 billion years of life on Earth, before the last 1,000 years, 10,000 years, depending on how you want to count, the background extinction rate on Earth is about 1 extinction per year. Every year, one species on Earth went extinct, if you look at the fossil record. So you look at the fossil record, most species survive about 1 to 10 million years. In 1 year, a species has a 1 in 1 to 10 million chance of going extinct. If you do those odds, every year you lose about 1 species on our planet as a background extinction rate. Now, humans have affected that quite a bit. But we'd have to understand extinction is kind of part of things that are going to happen, whether it's species changing over time and becoming distinct species, or species diverging and becoming 2 different species. Best estimates from the fossil record indicate that more than 99%, I think the number I've seen now is 99.999% of all species that have ever lived on Earth are now extinct. Now that means they either developed into a different species or just went extinct and their lineage died out. So it can be a couple different things. So a typical lifetime for species, like I said on the last slide, is about 1 million years, between 1 and 10 million years. So if you look at hominids have been around for about 1 million years, you know, not to be scary or crazy because humans have different rules when it comes to these types of things, but you know, the Homo sapien species, if it followed that rule, would kind of be in that ballpark. All right, some other things. This doesn't happen consistently. It's not like every year you lose a species, because you get mass extinctions. And there's been 6 mass extinctions in the fossil record since the beginning of life on Earth. Now, we talk about, you know, the 65 million year ago extinction. We talk about the last great extinction, which was the Mesozoic extinction. I can't remember the name. That my earth science is failing me at the present moment. But the last great extinction where the dinosaurs, you know, went extinct. Now, we've all, well, maybe we haven't all seen The Land Before Time, but we all have this idea of it like The Land Before Time. You know, dinosaurs are happily walking around and enjoying their daily life, and all of a sudden the volcanoes start to erupt, and an asteroid hits, and the ground starts to split, and Littlefoot's mother's on the other side, and everybody's screaming and yelling and crying. The dinosaur extinction actually lasted about 1,000 years. So for that, you know, that first opening scene in The Land Before Time, really from a fossil record standpoint, it lasted over about 1,000 years. So it's not like all of a sudden one day, when I say a mass extinction, I don't mean daily you lose thousands of species. I'm talking about you lose a lot more species over a shorter amount of time. And a lot of scientists are saying that we're living in a mass extinction right now because of the loss, the rate of species lost, instead of because of an asteroid, because of humans and what humans are doing to the planet. So usually to a catastrophic volcano or meteor impact, like I said, 5 to 6 times in the past 3 billion years, depending on who you ask. The current rate of extinction, that's one of those things I was saying, we'll get to that in a second. A lot of people say that maybe we're in the midst of a mass extinction right now. So looking at the history of, you know, this is going back 600 million years, and this is showing you these spikes in mass extinction. This one right here is the dinosaurs extinction. I believe this one, which is the big wide peak right here, is the Devonian age extinction, where 99% of all of the fish in the ocean died. And if you look at the fossils in the ocean, you see this over a few 100 million years or 50 million years or so, you lose an incredible amount of diversity in the oceans. And so just looking at, you know, how things work, and then you have, you know, what's that?
The short one, that's why.
Right here?
No.
This one?
Yeah.
It's just an early extinction. I'm not versed enough to know to tell you. I used to have a chart. Is my chart still up? No, I took the chart down. I used to have a chart that shows the mass extinctions. It's around here somewhere. And this is something that's about 15 years old. I think that this has been confirmed rather than, you know, we've had any evidence in the past 15 years to show the opposite of this, is that we're losing species at the greatest rate since that last mass extinction. And so the likelihood that we're in the midst of a mass extinction right now, it's actually pretty high. So what are we doing to do that? How do we cause species declines? And we're going to go through each one of these. Habitat destruction and fragmentation. Fragmentation, we talked about on the last APID test, is where you build that highway down the middle of the forest. Even if you're careful, just separating the habitat can make a big effect. Introduce species, that's what your project is on, that you're working on today and tomorrow. Exploitation, killing too many, over harvesting, taking more than is sustainable. Pollution, pretty straightforward, and then climate change. So looking at why things go extinct, percent of species affected by each thing, almost 90% of species in the United States have some amount of habitat destruction or fragmentation because of due to humans. That's pretty wild if you think about it, is that nearly all the species in the United States have some type of habitat destruction going on. Almost half of all species, I got you. Almost half of all species, you're fine. Almost half of all species have some type of invasive species that's affecting them. The alien species or invasive species or introduced species or exotic species that are affecting them. Then you have, this is actually pretty low, I think that's a good thing, that about 25, a quarter of all species in the United States are affected by pollution, overexploitation, and then a little bit on disease there. Some of you guys had a problem with finding Tupelo leaves. One of the problems with finding Tupelo leaves is that there's a blight that's affecting the Tupelo population. When I was in high school and did this leaf collection, Tupelo was everywhere, and it was one of the easiest ones to find. It was one of the things I even remember thinking that it's like oak, maple, Tupelo, they're everywhere. You guys, a bunch of you, had problems finding Tupelo. Luckily, I've got 3 or 4 at my house that we're able to help you out with. Some of you found them without coming to the house, great job. But if you look at a Tupelo tree, there's this weird gnarled section on the tree, and many of them that this blight that's affecting them. That's that disease. Why it's happening, you know, could be, you can research and find out. All right, so looking at some examples of this, we already talked about fragmentation, splitting up the habitat. Even if you are very careful not to infect species, if you build a highway down the middle of the forest, maybe you have a jaguar that normally would cross that highway, and you're really affecting what they're doing. So an example of just one organism here. So I don't know the name of this guy here, but cute little red monkey in Brazil, showing you a state in Brazil called Bahia. If you zoom on in, this was the range of that New World monkey, 1946, all the green. As people came in, this organism's population has been isolated, it's been fragmented. And so it's still there, still protected, it's still able to live, but it can't do what it did once, and so it wouldn't be sustainable. All right, what you're going to work on today after we're done is introduced species. This can sometimes be accident, or it can be deliberate. Years ago, in southern United States, they introduced this South American guy called a nutria. Nutria is a chubby beaver with a rat tail. And the reason that they introduced it is because it was really, really good for hunting and getting pelts. Really easy to catch, really easy to shoot, really easy to skin. I can get pelts. Let's bring them up here, let them reproduce. We'll have lots of them to hunt. What do you think a problem might have been? Okay, we're throwing them into a food web that they've never been in before. So maybe they eat things that other things would be eating, or maybe you have nothing to compete against them, or maybe you have nothing to eat them and they go unchecked. And that's exactly what happened. In New Orleans and Florida, in Louisiana and Florida, they had huge problems with nutria 50, 60 years ago. And now, if you go to the creeks here in Eastern North Carolina, you're gonna find nutria, because these guys they don't have any competition. They don't have anything that kills them. There's no, the food web that kept them in check in South America isn't here. And so you have these that completely throw away and change our food web. So I'm not gonna talk about too many more of those because I know you guys wanna knock out those, but invasive species, I wanna make sure when you do it, tell me whether it's deliberate or accidental. On an island, this could be a huge problem. because you have a small group of the gene pool. You introduce that organism into the gene pool, you can completely demolish, decimate an island's population just by bringing something that doesn't belong. Hello, hello, or goodbye, I'm not sure which one. All right, some other things real quick. Exploitation, over-harvesting, catching more than you need or catching more than the ecosystem can support. Bycatch in fishing, where you catch something that's not what you're aiming for, where you accidentally get turtles and dolphins in your nets. A lot of times you can't help them when they get caught. Maybe they die. Maybe there's no other way to deal with it. Okay, so bycatch in fisheries, and then one of the things that we never really think about because it happens in other countries is the idea of bushmeat. Now this sounds kind of weird, but in especially South America and Africa, if you want to cut down a lot of trees, you're going to need a lot of labor. You don't bring, if you're coming from Europe or United States to those places to cut down a lot of trees, you're not going to bring workers with you to actually work. You're going to bring managers with you. And then when you get there, you're going to hire a bunch of people. Well, when you hire a bunch of people to go off in the middle of the woods and work, they want to eat. And so a lot of times they will hunt and kill things that weren't used to being hunted and killed because of where they, because of where they were. And once again, it can be sustainable, but a lot of times the animals that are easy to catch, easy to kill, and easy to eat are your top level predators that aren't the safest to eat and also can damage your ecosystem the most. So looking at fish stocks and how fish stocks have changed, you know, a lot of fish are being overfished in modern times, and you have places where you used to be able to catch fish like crazy that you're just not able to do so. Then finally, you have pollution. We'll talk way more about pollution later, but if you pollute an ecosystem, we talked about bioaccumulation on the essay on the last test. You put a little bit of chemical in an ecosystem. One of the things on the last test too, that a lot of people miss, I think I had 1 or 2 people get it, is that first step in the food web. It wasn't listed up there, but you know, zooplankton have to eat something. They eat phytoplankton. Phytoplankton is the microscopic guys that are the lowest amount, the pond water number. That would be your phytoplankton, and then it accumulates on up, and you end up killing your top level predators, even though you're not aiming at them. So this is the problem that happened with DDT. DDT started killing all your top level predators, things like birds, eagles, hawks, and instead of the bugs that they were aiming for. So this is an example of that. You have the plankton in the water. They have 1 part per thousand. And by the time it gets up to the bald eagle, it's up to 110 parts per thousand, 11,000 times as much poison at the top of the ecosystem. And then climate change is something we're going to talk about a whole lot coming up, something you probably have heard a lot about. Something that's happening as we speak. You know, we're talking about the past 1,000 years or so. You have some temperature change on a small scale, but nothing like we've seen over the past 25 years. Nothing like we've seen over the past 30 years, and projections show it's coming in the future. We're talking about a change in our ecosystem unlike anything that we've ever seen. Now, my dad is a big proponent or a big skeptic about climate change, and we talk a lot about it. And it's not that he doesn't believe it exists, it's that he says 2 degrees warmer sounds good. Less snow, longer summer, bring it on. The problem with 2 degrees warmer is not today it's 2 degrees warmer. The problem with 2 degrees warmer is 2 degrees warmer on all the oceans. And you have a difference in how the wind blows, how the currents move in the ocean, and how the wind blows above those currents. And you start having a difference in how the wind moves, you start having a difference in weather patterns. You start completely changing the climate of certain ecosystems so that they are not sustainable anymore. You turn deserts into flood plains. You turn floodplains into deserts. You turn temperate deciduous forests into scrubland. That's the problem with climate change. The problem with climate change is not, oh, it's going to be a little bit warmer. And yeah, to some extent it kind of is, because you have polar ice caps and things and you have sea level rise. But that's that. The other big thing that we have to understand is that we are changing our ecosystem faster than our animals can keep up. Some animals are going to be able to keep up. Bacteria, they're going to be just fine. Roaches, they're going to be rocking and rolling, okay? But your top level predators, your macroscopic organisms, your big mammals, your big reptiles, they can't change fast enough to meet the changing ecosystem. All right, and I'm going to hold off on the future of evolution. We'll talk about that maybe later or another day. So if there's no questions, I'm going to stop there, and I'm going to give you the rest of the day to get started on your invasive species project. Check out your Change the World project as well. Once again, you have a little bit of time on the invasive species project. Let's go ahead and start that, get some learning done on that, but also jump on that Change the World project. Be in communication with me. Give me any ideas that you have. I don't want 10 people in class doing the same thing, but I also don't want you to devote time on something that I think is maybe a little bit too hard to do, or something that's beyond your scope, or something that's too simple. So be in communication with me this week. Give me your ideas for your Change the World project. I'll tell you whether it's good or not. I'll give you an example of one that you're not going to be able to do because this ship has sailed. But I had one student that said he wanted to, he was joking, and he said, look, I'm going to save gas by just riding my unicycle every day instead of driving my car around. This is my first year ever teaching this class. And I was like, dude, you live in Ayden in the Pines by McDonald's. There's no way you can ride your unicycle to work. And so he said, yes, I can. And I said, dude, you can't. And so I called his bluff, and I said, if you ride your unicycle to work, or so if you ride your unicycle from your house to Ayden High School without touching the ground and film it, I'll give you a 100 on the assignment. You don't have to do anything else. Guess what he did? So obviously that's not an acceptable thing for anybody to do. No, that ship has sailed. But there's lots of different options of things you can do. You can plan and do something that it's not that you have to do something every single day. It's that the scope of it needs to be that 30 days. So I've had this happen good, and I've had this happen bad, because I always mention it and everybody's like, ooh, that sounds like fun. I've had people do it great, and I've had people do it terrible, where they plan and pull off 24 hours living completely off of the grid. No electricity, no help with them. I had two students specifically, one's actually a teacher at Formal Central right now, who carried nothing but a couple of knives and fishing poles into Contentney Creek swamp and filmed themselves living for 24 hours and eating crawfish, and it was freaking amazing. Flip side of that is I've had some people attempt it, and you can see the Bojangles bag in the back of their videos. So understand that, you know, be really creative with what you're going to do. It is vague in directions on purpose, because I want you to be creative. That's why I need you to be communicative with me during this time. Any questions? Got a crowd of folks in the Zoom. Any questions? All right, guys. Go ahead, sorry.
I said no.
You the man, Owen. All right, y'all have a great day, and shoot me any questions or emails, or I'll be glad to talk to you, and I'll see you tomorrow.